Okay, guys, today we're going to finish up Unit 10, Section 1. I'm going to be talking about the law of conservation of mass and something called balancing equations. So earlier in this chapter, we learned about skeleton equations, which are just the basic reactants and products that take place in a chemical reaction, but it does not account for the total amount of substances, like how many reactants, like in terms of mass or volume, react together to form what mass or volume of products. Okay, so all equations have to be balanced so that they obey what's called the law of conservation of mass. Now, today I'm not going to actually teach you how to balance an equation per se. I'm just going to give you kind of a step-by-step procedure on kind of working our way up to balancing the equation. Okay, so a chemical reaction has to be described by a balanced equation in which the number of molecules and atoms, so I should say, sorry, the same number of atoms of each element has to be the same on both sides. So if you look at the reaction at the bottom, it shows one carbon atom on the left and one carbon atom on the right. It shows two oxygens on the left, two oxygens on the right. If any one of those numbers was off, it's not a balanced equation because you can't create or destroy atoms. So the mass has to be the same on the left and on the right. Okay, so the law of conservation of mass says that atoms are neither created nor destroyed. So all atoms must be accounted for when we write a chemical equation. Okay, so meaning you have to have the same number of each type of atom on both sides of the equation because the atoms cannot be created or destroyed or turned into another atom in a chemical reaction. In nuclear reactions, that is not true. The law of conservation of mass does not hold true in all cases, but for chemical reactions it does. Okay, so in order to fix the skeleton equations, which we were doing earlier in this chapter, we need to balance the equations by adding coefficients in front of the products and reactants. So if you look at the reaction below, you see the 2 in front of the H2, and you see a 2 in front of the water. Okay, those 2's are called coefficients. It tells you the number of that, how many of those molecules or atoms you have. So this equation says 2 hydrogen molecules react with 1 oxygen molecule to form 2 water molecules. So the coefficients tell you how many of each molecule you have. Okay, now, some key things you have to remember. If you do any of these things, you're going to screw these up. You can never change a subscript to balance an equation. The subscripts determine the molecule, the structure of the molecule. You can only change the coefficients in front of the molecules or atoms. Okay, if you change the subscript, you change the identity of the chemical substance you're talking about. Okay, so H2O is a completely different compound than H3O. You can't just change the 2 to a 3 because you need an extra hydrogen. It doesn't work that way. Okay, also, you can never put a coefficient like in the middle of a chemical formula. They can only go in the very, very front of the chemical formula. So that coefficient will apply to every atom in the molecule. Okay, so for example, 2NaCl means you have 2 salt molecules. They're not actually called molecules, but whatever. And that's okay, but you can't say Na2Cl like that. That 2 is a coefficient. You see, it's large. If it was a subscript, that'd be a different scenario, but you can't put a large 2, a coefficient, in the middle of a chemical formula. Now, when a coefficient is placed in front of a molecule, it gets distributed to all of the atoms in that compound. Okay, so for example, 2MgO means I have 2 magnesium atoms and 2 oxygen atoms. If I have 2 water molecules, it means I have 4 hydrogens, 2 oxygens. The 2 distributes. So 2 times 2 gives me 4 hydrogens. Okay, now the ones that are most complicated are the ones that have the parentheses. Here you have to take into consideration the 2 on the outside of the parentheses and the 2 in front. So some of you are probably going to struggle with this at first. So first, the Mg, I just have one of them in the compound. So 2Mg means I have 2 magnesiums. Okay, now oxygen and hydrogen are the tough ones because they're inside the parentheses. So first, if you take the 2 and you distribute it, the 2 subscript, and you distribute it to the oxygen, I have 2 oxygens in one compound, but I have 2 compounds. So 2 times 2 gets me 4 oxygens and 4 hydrogens. Okay, so here's some more practice. I would prefer that you actually pause the video right here, take a second, try to figure these out on your own before you continue the video where I give you the answers. Okay, so 2Al, that one's obvious. I just have 2 aluminum atoms. Okay, 3H2, 3 times 2 gets me 6 hydrogens. 4CO2, I have 4 carbons and 8 oxygens because 4 times 2 is 8. 3K3PO4. 3 times 3 gets me 9 potassiums. 3 times 1 gets me 3 phosphorus. 3 times 4 gets me 12 oxygens. Now, number 5 is the tricky one. This is where you got to distribute subscript and coefficient. So 2NH4 2CO3. Okay, so in each one of the compounds, I have 2 nitrogens because the 2 on the outside of the parentheses distributes to the nitrogen. Now I have 2 of the compounds, so 2 times 2 gets me 4 nitrogens. Okay, in each of the compounds, I have 4 times 2, which is 8 hydrogens, but I have 2 compounds, so 2 times 8, or which is the same thing as 2 times 4 times 2, gets me 16 hydrogens. Then carbon's easy, just 2 times 1 gets me 2 carbons, and then oxygen 2 times 3 gets me 6. Please make sure you guys can do this, because if you can't do this right here, you won't be able to do anything else the rest of the chapter. This is key that you guys can understand where these answers came from. So if you don't, keep looking at them over and over until you figure them out. Now, as I said, in chemical reactions, mass is neither gained or lost, can't be created or destroyed. So the mass of the reactants has to equal the mass of the products. The atoms just get rearranged. Chemical bonds are broken, new chemical bonds are formed. They're neither created or destroyed. So if I give you a simple example like this, you should be able to figure out the missing variable. It says if 48 grams of magnesium reacts with 32 grams of oxygen, how many grams of magnesium oxide are formed? Okay, so first off, I'm going to write it as a basic, like a math equation. So I write 48 grams of magnesium plus 32 grams of oxygen, and I put the equal sign where we normally have the arrow because I'm making this like a math equation to make it easy for you guys. And then I put X grams of magnesium oxide. X is our missing variable. That's what we're trying to solve for. Just think of this as math class. So if you had to solve for X right here, clearly you just add 48 and 32 and you get 80. Because the mass of the reactants has to equal the mass of the products. I have 80 grams of reactants. I have to have 80 grams of products. Okay, so the mass has to be equal on both sides of the equation. Okay, now example 2 is a little bit trickier. You're going to require a little bit of algebra here, but it's just multiplying and dividing. Adding and subtracting. If 74 grams of sodium bicarbonate decomposes, which means breaks apart, and it forms 9 grams of water, 22 grams of carbon dioxide, how much sodium carbonate is formed? Okay, so first off, I wrote it as a chemical equation. I know you guys aren't very good at these yet, so I'm just giving it to you right here. You guys remember early in the year, we learned how to write chemical formulas and stuff. Hopefully you guys remember that. The ionic compounds, you had to balance the formula, like CO3, if you look on your ion sheet, has a -2 charge. Sodium has a +1. That's why it's Na2CO3. So I'm hoping you guys remember how to do that kind of stuff from earlier in the year. Okay, so now I'm going to make it a math equation. I'm going to add the numbers from the paragraph above. So I have 74 grams of sodium bicarbonate equals the products. X grams of sodium carbonate, which is what I'm trying to look for, 9 grams of water, 22 grams of carbon dioxide. Now, if I gave you this question in math class, obviously you just take the 9 and the 22 and you subtract them to the other side, and that leaves X by itself. So X equals 74 minus 9 minus 22, and you should get 43. Okay, so if you put 43 in where X is and you add it up, 43 plus 9 plus 22, you'll see you get 74. The reactants and the products have to equal each other. Okay, there's a few review questions in your note pack at the end of section 1. Please answer those review questions. Show all work where necessary. Let me know if you guys have any questions.